Euclid of Alexandria was a Greek mathematician known as the father of geometry. Little is known for certain about the circumstances of Euclid's life. There are few references to his birthplace and date. It has been suggested that he was born around 300 BC, somewhere in Greece. The circumstances surrounding his likeness or physical appearance are also unknown. For all we know, he might well have looked like this.
There is only so much we can infer about the life of Euclid. For instance, we can say that Euclid came from a rich family, since he was educated at Plato's school in Greece, where all the rich kids studied.
Records suggest that Euclid was considered a nice yet sarcastic person.
The Greek civilization has provided the world with much of its knowledge on various areas, including mathematics. From the viewpoint of its mathematics, it is best to distinguish between the two periods, the classical period from about 600 BC to 300 BC, and the Alexandrian or Hellenistic period from 300 BC to 300 AD. Indeed, from about 350 BC, the center of mathematics moved from Athens to Alexandria in Egypt, the city built by Alexander the Great. By then, many of the Greek schools of thought had been founded, such as the Pythagorean school, which studied proportion, number theory, theories of proof, and others, the school of Eudoxus, which studied irrationals, the notion of magnitude, and others, and the school of Aristotle, which viewed the sciences as three: theoretical, productive, and the practical.
Euclid was a student at the school of Plato, participated in this migration of the center of mathematics from Athens to Alexandria. Euclid's greatest contribution to the world is the Elements, a long, exhaustive text on geometry and number theory. No other book except the Bible has been so widely translated and circulated.
Elements is a mathematical and geometric treatise consisting of 13 books. It is a collection of definitions, postulates, propositions, and mathematical proofs of the propositions. The 13 books cover Euclidean geometry and the ancient Greek version of elementary number theory.
The work also includes an algebraic system that has become known as geometric algebra, which is powerful enough to solve many algebraic problems, including the problem of finding the square root. Euclid's Elements has been referred to as the most successful and influential textbook ever written. Being first set in type in Venice in 1482, it is one of the very earliest mathematical works to be printed after the invention of the printing press. Book 1 through 4 deal with plane geometry. Book 5 through 10 introduce ratios and proportions. Books 11 through 13 deal with spatial geometry.
The ideas of Euclid put forth in his book works could be extended to practical applications, such as bridges and towers and churches and buildings and bridges. For example, let us consider advanced architectural achievements, such as this bridge. The use of geometrical shapes helps give the bridge a rigid and stable structure. The precise application of Euclidean geometry is of utmost importance to guarantee the safety of our society.
It is also useful to use Euclidean geometry for activities such as studying global historical landmarks, such as the renowned Tower of Pisa. For instance, we may calculate the angle the tower makes with the ground, which in turn could help us understand how the tower remains erect.
Another application to Euclid's The Elements could be Book 2, commonly called the Book of Geometric Algebra. Most of the propositions in Book 2 can be seen as geometric interpretations of algebra identities. A plus b squared equals a squared plus 2ab plus b squared.
We can see here from the squares what Euclid meant. Although a few records remain of Euclid's life, we know it was a great one. We have no indicatives of how this great man came to pass, so we can only suppose. Perhaps he was brutally murdered while being mugged. or murdered in his sleep? Maybe he was a victim of a jealousy rage. Alas, we do not know what brought the downfall of this great genius, but what we do know is that he lives on in his works and in our hearts.